The last quarter of 1968 may well be termed the most significant 3 months in the 10-year history of the American space program. Early in the quarter, on October 10th, Apollo 7 was in the last hours of its countdown. That same day, 10 miles away, Apollo 8 was moved from the Vehicle Assembly Building to Launch Pad A at Complex 39 for its flight in the latter part of the quarter. At 11 a.m., October 11th, the first manned flight of Apollo commenced what was to become known as a textbook flight. Liftoff of the 1,300,000-pound vehicle was perfect. Separation of the first stage occurred at 2 minutes, 25 seconds after launch. Although many tests were programmed for Apollo 7, the overall mission objective was to prove the command and service module under space conditions and for a time period equal to 11 days. One of the major tests was to separate the S-4B stage and the command and service module. The command and service module would then move forward, turn around, and return to the second stage and simulate docking with a lunar module. This was done. The 4 panels radiating from the second stage presented a minor problem since inception. They have been redesigned and, beginning with Apollo 8, will be completely jettisoned. On board, command pilot Schirra and pilots Cunningham and Isley demonstrated that men could live and work in space with increased comfort and efficiency. All spacecraft systems were used and tested exhaustively. All performed according to plan. The few minor problems that did develop, such as an overloaded electrical circuit, a malfunctioning fuel cell, were quickly taken care of in flight by adopting revised operational procedures after consultation with Mission Control. Splashdown occurred at 7:11 a.m. on October 22nd, within 8 miles of the recovery carrier. The flight of Apollo 7 lasted exactly 10 days, 20 hours, 9 minutes, and 45 seconds. Made 164 revolutions around the Earth. Traveled more than 4.5 million miles, and added immeasurably to the confidence level of our space program. With the successful conclusion of Apollo 7, attention centered quickly on Apollo 8. The flight plan for Apollo 8, defined earlier as another Earth orbital mission, had been held open pending the success of Apollo 7. With the results in, the job for Apollo 8 began to take shape. Throughout the country, at NASA headquarters and field centers, millions of data bits and performance records were collated and analyzed. Every moment of the 11-day flight of Apollo 7, every factor, human and mechanical, was scrutinized. The near-perfect performance of Apollo 7 was scientifically confirmed. Then, following a review of previous Apollo flights, and after a thorough assessment of the total risks involved and the total gains to be realized, the decision was made to send Apollo 8 on a flight to lunar distances, and perhaps into lunar orbit. On December 5th, Apollo 8 was on schedule and began the critical countdown demonstration test. The test is conducted in 2 parts. The first part is a full dress rehearsal of all launch activities to T-9 seconds. This includes actual fueling of the Saturn stages and other components. After the fuel was removed from the vehicle, the Apollo 8 crew, Commander Frank Borman, Command Module Pilot James A. Lovell, Jr., and Lunar Module Pilot William A. Anders, suited up and entered the spacecraft at T-2 hours and 40 minutes and proceeded to perform all spacecraft activity leading up to simulated liftoff. While much attention was now focused on Apollo 8, the balance of the manned space program moved ahead and on schedule. For the first time, 3 Saturn V vehicles were under assembly in the Vehicle Assembly Building. Early in the report period, all stages of the Saturn V launch vehicle for Apollo 9 had been mated. The Command and Service Module arrived at the Manned Spacecraft Operations Building in early October. Among the important tests performed were the unmanned and manned altitude tests, which involved both the prime and the backup crews. The lunar module for Apollo 9 also underwent vigorous testing. Of special interest was the lunar landing gear. The legs, extended here, are folded in and under the lunar module during launch and lunar trajectory. By the end of November, all components of the Apollo 9 spacecraft had been man-rated. Mating to the launch vehicle took place in early December. Apollo 9 is scheduled to move to the launch pad on the 3rd of January, 1969. In another bay of the Vehicle Assembly Building, Apollo 10 was beginning to take shape as the report period ended. The last components, the second stage and instrument unit, were delivered on December 10th and 13th. As the quarter ended, Apollo 10 was on schedule. In the next high bay, the tools and hardware were being made ready for Apollo 11. The lunar module for this spacecraft has been received at the Kennedy Space Center and is now undergoing tests. Also, during the report period, launch complexes 34 and 37 were temporarily deactivated. This was a result of the closeout of the Saturn 1B program after the Apollo 7 mission. The facilities will be kept on standby for use in the Apollo Applications program scheduled to begin in 1971. At the Michoud Assembly Facility, the last 2 Saturn 1B stages are under assembly. Upon their completion, this portion of the facility will be placed on standby status, retaining minimum personnel. The Apollo Applications program moved along a broad range of activities. The major milestone during the quarter was the successful completion of the preliminary design review for a modified lunar module. In this design, an Apollo lunar module ascent stage is being modified to serve as a control station and carrier for the Apollo telescope mount. At Marshall Space Flight Center during the quarter, engineering development tests were performed with a Saturn I workshop full-scale mock-up in a neutral buoyancy simulator. The objective of these tests is to evaluate workshop hardware design under conditions simulating a zero-G environment. Here being tested is the hardware for sealing openings or penetrations in the aft dome of the stage. The sealing of these and other openings is necessary so the stage can be pressurized for human occupancy and conversion to a workshop. Near the end of the quarter, on the morning of 21 December, Apollo 8 stood with all systems go.
13, 12, 11, 10, 9. We have ignition sequence start. The engines are armed. 4, 3, 2, 1, 0. We have commit. We have liftoff. Liftoff at 7:51 a.m. Eastern Standard Time.
Liftoff was exactly on schedule. The mission for Apollo 8 was termed the Command and Service Module Design Mission. That is to perform all of the details of a lunar landing mission with one difference. The lunar module on Apollo 8 is a test particle representing the volume and the weight of a lunar module. Therefore, the mid-course turnaround maneuver, the rendezvous, docking, and lunar landing maneuvers will not be performed. Apollo 8 was also called an open-ended flight. It was conducted in steps referred to as commit points. At each point, a thorough analysis of crew, systems, and equipment was made. Only when all conditions were satisfactory was the decision made to proceed to the next commit point. That the system worked well is borne out by the details of this remarkable space venture. First stage separation occurred precisely on schedule, and while mounting world attention focused on Apollo 8, intent men in the command module, in control rooms, ships, planes, and tracking stations bent themselves to the strange new task of leaving their planet on a lunar trajectory. The first commit point was called translunar insertion. During 2 revolutions of the Earth, the crew checked spacecraft and launch vehicle systems in preparation for reignition of the 3rd stage. Simultaneously, Mission Control evaluated all space vehicle parameters, communications, and ground tracking facilities. Everything was in order, and the go for translunar insertion was given. The 3rd stage performed its function perfectly, and 5 minutes, 19 seconds later, Apollo 8 was traveling at 24,200 miles per hour toward the moon. 20 minutes later, 3rd stage separation occurred. Soon thereafter, the crew removed their pressure suits. They wore lightweight flight suits throughout the remainder of the mission. The first mid-course correction occurred 11 hours into the flight. The resulting trajectory was so accurate, the planned 2nd and 3rd course corrections were not required. During translunar flight, the astronauts conducted star, Earth horizon, and lunar sightings to demonstrate the accuracy of onboard navigation and to evaluate the optical subsystem for future deep space manned missions. Another commit point was approaching as Apollo 8 neared the moon. If no further maneuvers were made, the spacecraft would merely circle the moon and head back to Earth on a free return trajectory. After an extensive evaluation of all systems, Mission Control and the astronauts decided to go for lunar orbit. The first service propulsion engine burn placed the spacecraft in a 96 by 193 mile elliptical orbit. A second burn put the spacecraft into its planned 69-mile circular orbit. Photography of the lunar terrain was excellent. At 96 hours, 46 minutes into the flight, Command Module pilot Jim Lovell gives man's first eyewitness account of the moon. After 20 hours in lunar orbit, 10 revolutions, the astronauts and Mission Control evaluated all systems and navigation data. All systems were go for trans-Earth injection. The service module engine was fired for 203 seconds. Once again, the performance of men and machine was exact and precise, so much so that only 1 mid-course correction was required instead of the 3 that had been planned. Thermal control of the spacecraft was practiced during the flight. This involves rotating the spacecraft slowly to prevent heat from building up on the side facing the sun. Apollo 8's primary guidance and navigation system was operated automatically for controlling the spacecraft's return trajectory. At regular intervals, Mission Control fed updated information into the command module computer. Earth re-entry was remarkably accurate. An airborne camera captured the last few fiery seconds of this history-making flight. The spacecraft splashed down in the mid-Pacific exactly on schedule and within 5,000 yards of the carrier Yorktown, and brought with it the inescapable conclusion that man can travel, navigate, and communicate in deep space with confidence and precision. From the liftoff to the splashdown of Apollo 8, the performance of men and machines in space and on the ground was certain and sure. All of the test objectives of the Command and Service Module Design mission were achieved. Thus, with 2 major and successful manned space flights in the last quarter of 1968, the American space program grew in stature and in confidence. The immediate future is equally optimistic. Apollo 9 in the final stages of flight preparation. Apollo 10 in the latter stages of assembly. Apollo 11 in the beginning stages of assembly. The increasing flow of hardware from manufacturers to NASA centers and from there to the launch site is a continuous and efficient operation, not just in terms of numbers, but in the all-important area of quality. A well-trained, cohesive team of thousands of men and women have been spread around the world to provide the intricate support activities required by space exploration. These factors, in the closing months of 1968, illustrate that our space program has reached a new maturity, and that this nation has attained the capability to operate in space 250,000 miles from Earth. The last quarter of 1968 may well be termed the most significant 3 months in the 10-year history of the American space program. Early in the quarter, on October 10th, Apollo 7 was in the last hours of its countdown. That same day, 10 miles away, Apollo 8 was moved from the Vehicle Assembly Building to Launch Pad A at Complex 39 for its flight in the latter part of the quarter. At 11 a.m., October 11th, the first manned flight of Apollo commenced what was to become known as a textbook flight. Liftoff of the 1,300,000-pound vehicle was perfect. Separation of the first stage occurred at 2 minutes, 25 seconds after launch. Although many tests were programmed for Apollo 7,